Hey Finxters, it's Chris, founder of Finxter.com, and in today's video you're going to learn about Python's object function. So this is one of Python's built-in functions, and it's the most basic function you can imagine. So the function works very simply. So in its basic form, and this is the only form you can use it. You don't pass any argument into it, and it will return an object, a basic object. And so what does it mean? So in Python, everything, like all objects, everything is an object. All functions are objects. You have like integer objects, list objects, set objects, float objects, string objects. So byte objects, everything in Python is an object. And all objects inherit from this base data type, from the object class. So it's like counterintuitive, but actually object is the name of the class, and you can create new instances of this class by using this object constructor. And for example, you can type in help and then pass an object, and then you see, okay, it's a class object. It's the most basic type. So all objects in Python basically inherit from this base object class, and you can create new instances from the object by simply calling it here. So you may ask, okay, so an object is basically we can assign the object to a variable, and now what many people try to do actually, so if you have a dummy class, you can then dynamically add new attributes to the object, but you cannot do it here, yeah. So you cannot add, say, my attribute and set it to 42. This will throw an exception, yeah. So the reason is that the object class doesn't implement the dunder dict method. So this method here, object then underscore, so twice the underscore, dict underscore. So this is not implemented, and therefore you cannot store, like on a basic object instance, you cannot add or associate new attributes to it. But this works, for example, if you have a class, say, let's call my class object like this. This naturally inherits from object, and say even if I don't do anything with the class, now I have this basic class defined. Now I can define my own object, now in uppercase, letters capitalized, and now I can do the same, yeah. So I can now associate my attribute to and set it to 42. So this is absolutely possible, and I can also check out the value, and then it will give me 42. I can even associate some functions, yeah. So my function, and I can set lambda x to x plus 1, for example, and now I can call object my function. I should have said method actually, because it's a method, and I pass, say, 10 to it, and it will simply calculate x plus 1, so 10 plus 1 is 11. Okay, so you can, like for all other objects, it basically works that you associate, dynamically associates new methods or new attributes to the object, but it doesn't work for the top level object instance of the class object, I should say. So terminology is quite confused, because object is the name of the class, and only if you use the constructor with it, it creates a new object of the class object. Okay, so a new instance of the class object. And so if you call the function multiple times, you get really different objects in memory. You can see it here with the memory address. This one here has like 27331DEE3A0, and this one has 27331DEE390. Okay, so we have different. So this address here, this part of the hexadecimal number is different. So we have different addresses in memory, which means that those are basically different. Yeah. So if you, for example, compare object equals object, it returns false. Also, if you use the is keyword that checks whether both refer to the same object in memory, it also refers to false. So each time you call the constructor object, it creates a new instance, a new object, and it doesn't like this is like if you do the following, none equals none, you get true, right? So you have like none doesn't create a new object in memory, so it is the same, and that's also like the most basic use case, that the object basically always each time you call the object constructor, it creates a new object. And So there are a few, like one of the purpose is that it's that it's used as a sentinel object, or also called dummy object. So I will quickly go over the code maybe. Let's copy this to make it really quick. So you can do the following. So you can use the object function. So you cannot change an object. So you may ask, okay, what is the purpose of the object function? If you can create an object, but you cannot change the object later. You cannot associate methods to it or attributes to it. So you basically cannot do anything with the object, right? Yeah, I mean, this is partly right, but there are some use cases where it really makes sense to use the object constructor. For example, here we use it as a sentinel variable, or also called dummy variable, and then we define a function step, and this is our iterator function. Yeah, so the iterator function, it returns, so it takes the user input and it asks the user for a number, and if the user input, only if the user types in stop, it returns the sentinel variable. So this object we have created here initially, there's only one sentinel object in memory. So this is like, it's the only dummy object. It's not like none. If you return none, then we can have multiple instances of none, or basically multiple references to none. But here in this case, object always, each time it's called, it's the only one. So it's the only address. Okay, and we use this as the dummy object, and we return the sentinel only if the user types in stop. Otherwise, we return the user input of this function. So this function basically most of the time will return the user input. Only if the user types in stop, it returns sentinel. Okay, and now we pass this function step. We pass it here into the iter built-in Python function that creates a new iterator, and we also pass the sentinel object. And so what does it mean? As soon as the iterator simply repeats calling the same function again and again until the function returns the sentinel object. So, and the sentinel object is defined as this unique object, this object here. It has no other purpose than to serve as a sentinel object. So as soon as we return this specific sentinel object, so the iterator basically checks for equality. As soon as this one is returned, the iterator stops. Okay, and it doesn't return anymore, and the iterator terminates. So basically this for loop goes until and repeats itself until you type in stop, and then it returns the sentinel object and it terminates the whole loop. So let's run this code. So here I'm asked your number. So say I type in 42, 36, 72, 333. So I like this never stops until I type in stop, and then it returns the sentinel object. So in this case, I have typed in stop. It returns the sentinel object, and this is an indicator for the iter function that it should now stop iterating over it, and there's nothing left in the iterator. And so this way you can dynamically create a new iterator out of any function, which is really great. And this function is then called again and again and again to retrieve a new element. So this is really useful because you can make any function an iterator this way. But you need to pass a sentinel object, and for this it's quite useful to use the empty object because it doesn't have any other purpose. So therefore it is only called once to serve as a creator function for the sentinel object, and that's it. It's never called again, and it's the only purpose. So, and it wouldn't make sense here to set the sentinel, say, to 42. I mean, this is just less readable. Of course, it would also work, I guess, but then maybe if the user types in 42, it could also lead to some problems because 42, it's an overloaded term. Also, if you use none, it could lead to some problems because this may be actually none may be a valid. So it depends on the function, of course, but the function may actually want to return none in some instances. Yeah, so in this case, maybe not, but in other instances, none would be a valid return value of the function. And then in this case, it would iterate over a list. Maybe the list contains none values. And then it would, at some point, it would return the value none, but there are still some elements left in the list. So therefore, but as it returns none, and we define none as a sentinel variable in this case, it would terminate the iterator. It would stop iterating over the list that also contains none values, and therefore it would do the wrong thing. Yeah, and this is really really hard to find, really nasty problems. So you can solve this problem by just passing an object into it and be done with it. And it's also very readable because I mean you see it's just a dummy object. Okay, it's just used as a dummy object. Okay, so I think that's enough for today's video about the object function. Thanks for listening to this video and see you in the next video. Bye.